Hi, I'm Mateenah, and I'm a computational scientist. I want to tell you a story about a project I did recently that, well, it just completely blew my mind. It's a story about curiosity, a seriously tight deadline, and an incredible new tool that could change how we fight some of the world's worst diseases.
Okay, so here it is. I used an AI agent to hunt for potential drug treatments for Alzheimer's disease, and I did it all in one afternoon. And get this, I don't have a PhD in bioinformatics. Nope, it was just me, some curiosity, and the right tool. So let me walk you through exactly how this all went down. So, first things first, let's talk about the problem we're up against: Alzheimer's. I mean, it is a truly devastating disease. It affects millions of people, robbing them of their memories, their personality, their independence. And the hardest part? Right now, there is no cure. And a huge reason why is just the way we develop drugs. Think about it. It can take 15 to 20 years and literally billions of dollars just to get one new drug to market. And after all that time and money, most of them just fail. It's pretty clear we need a better way to do this. A smarter and definitely a faster way. This is where this really clever strategy called drug repurposing comes in. The idea is actually super simple. Instead of building a brand new drug from scratch, what if we just take drugs that already exist, ones we know are safe, that are already approved, and just find new jobs for them? And that was the exact mission I decided to take on with a little help from an AI copilot. All right, so let me introduce you to the tool that made all of this possible. And I'm really not exaggerating when I say this thing is a total game changer for medical research. Okay, meet Biomni. The easiest way to think of it is like a super intelligent research robot. Seriously, you give it a question and it just goes. It makes a plan, it automatically starts digging through dozens of scientific databases, it even writes and runs its own code to get the job done, and then it just hands you the results. Now, the brain powering this robot is a powerful AI called Claude. So the setup was pretty straightforward. Biomni was the body, Claude was the brain, and I was just the person asking the question. Now, this is where the story gets a little crazy. I just happened to stumble upon this live competition, the Biomni Adapt Discovery Prize. It had a $1,000 prize, and the challenge was to use Biomni to make a real, actual testable discovery about Alzheimer's. But here's the kicker. The deadline was that same day. The clock was literally ticking. So yeah, I jumped right in. So I had my tool, I had this insane deadline. And now I needed to choose the right question to ask. And to do that, I had to tap into this huge shift that's been happening in Alzheimer's research. This move away from a single, really narrow focus to something much, much broader. You see, for about 30 years, almost all the research focused on just two things, these toxic proteins called amyloid plaques and tau tangles. The idea was, hey, if we can just clear out this gunk from the brain, we can cure the disease. But it just didn't work. Drug after drug failed. Why? Because Alzheimer's isn't just one broken thing. It's more like a house on fire. The amyloid, that's just the smoke you can see. The real problem is that there are fires burning in 6 different rooms all at once. And that's what I told the AI. Go find the source of those fires. So these are the 6 fires. First, you've got neuroinflammation, where the brain's immune system just goes into panic mode. Then there's lipid metabolism, where the system for moving fats around breaks down. Autophagy, that's like the cell's garbage disposal just quits, so junk piles up. Then there's epigenetic regulation, where the wrong genes get turned on. Energy metabolism, the power plants in the brain cells literally run out of fuel. And finally, synaptic maintenance, where the actual connections between brain cells fall apart. My instruction to the AI was simple. Find drugs that can put out these fires. So I wrote up a really detailed research prompt. You can think of it like a very precise set of instructions. And then I just hit run. And for the next 2 hours, the AI agent worked completely on its own. And this is what it did. First, it downloaded a mountain of data, 11 gigabytes worth. Then, it combed through all of that to find over 3,000 genes linked to Alzheimer's. Next, it mapped those genes to our 6 fires. After that, it used a neural network to predict which drugs could target those problem areas. And finally, it delivered a ranked list of candidates. I want to be really clear. I didn't do any of this manually. The agent planned and executed every single step, all by itself. And here's what it found. This is just a little snapshot of the top results. You've got minocycline, an acne antibiotic that might be able to calm the brain's immune cells. Simvastatin, a super common cholesterol drug that could help fix fat transport. Even lithium, used for bipolar disorder, showed up as a way to protect brain connections. The variety was just incredible. drugs for diabetes, cancer, infections, all identified as potential treatments for Alzheimer's. Getting this list was amazing, a real wow moment. But what I did next is honestly the part I'm most proud of. And I think it's the most important part of this entire story. It's the human audit. I went back and I read through the AI's entire work log step by step. And the whole time, I was asking one crucial question. Where did the real data end, and where did the AI's own reasoning begin?
And here's the honest truth of what I found. Pulling the genes, mapping the pathways, making those initial drug predictions, that was all solid. It was all based on real data from established databases. But the final ranking, and especially the detailed explanations of why each drug was a good candidate, that was synthesized by the AI. It turned out a software component was missing, so when it couldn't check one last database, it just filled in the gaps itself.
And that right there is the core lesson. As these AI agents start doing more and more science, we can't just take the final polished result and run with it. We have to be transparent. We have to show exactly where the hard data ends and where the AI's reasoning begins. That line is everything. It's the difference between a confirmed scientific finding and a promising, testable hypothesis. So, what does this all mean for the future? Well, it means we are entering an era where the pace of scientific discovery is about to accelerate beyond anything we have ever seen before. Just think about it, the ability to go from a question to a full genetic analysis, to pathway mapping and a list of testable hypotheses, all in one afternoon. That was pure science fiction just a few years ago. This process would have taken a team of specialists months, maybe even years. I submitted the full project, including the audit, and it was validated by the research community. And this brings me to my final question. I'm just one person. If a single researcher can do this in an afternoon with a free open source tool, what happens when thousands of scientists all over the world have this power? What new frontiers will we explore? What problems are we finally going to solve? That, to me, is what's next.